Today's topic is functions. Here we discuss about functions, domain of a function, range of a function, vertical line test and number of functions. Okay, these are the topics under functions. Definition of a function, domain, range, vertical line test and number of functions. A relation f from a set A to a set B is said to be a function if every element of set A has one and only one image in B. Consider a set A 1, 2, 3 and another set B which consists elements A, B, C, D, and a relation from A to B. Now 1 to A, 2 to B and 3 to C. Every element of A has unique image in B. So this relation is a function. Every element of A should possess an image and that image should be unique, one and only one image. This A is called image of 1 and 1 is called pre-image of A. Now consider another relation from A to B, 1 to A, 2 to B, and there is no arrow from 3. This 3 has no image. So this is not a function. Here from each element there is only one arrow mark. So this is a function. Now here from 3 there is no arrow. So this is not a function. Now in this case there are 2 arrows or 2 images for this element 2. And also 3 has no image. So this is not a function. Every function is a relation, but relation need not be a function. These two relations are not functions. Now consider a set A. This set A consists students in a class and here set B is teacher. And the relation from set of all students to teacher is a function. There is arrow from each students to this element T and there is only one arrow mark. Now the reverse is relation from teacher to this set of all students is not a function. Now here there are more than one images. Now consider a relation from set A to B. Now this U, B, A, N, S. Okay, what is U, B, A, N, S and P? Yudhishthira, Bhima, Arjuna, Nakula, Sahadeva, and P is Panchali, Pancha Pandavas. Now this relation is a function, and now consider a relation from P to U, B, A, N, S. This is not a function. Now these are the different forms of a function. F from A to B, where A is equal to set 1, 2, 3, B equal to set 6, 7, 8, 9. Now this is roster form of function 1, 6, 2, 7, 3, 8, and this is known as arrow diagram, and here this is set builder rule or a rule, set builder form or rule which indicates F. F is from A to B. Now here 1 to 6, 2 to 7, 3 to 8. Set of all x values is known as domain of the function. Now in this case set 1, 2, 3 or this whole set A is the domain, and the second set, this set B, is known as codomain of F. This is domain and the whole set B is known as codomain, and range of a function is the set of all y such that xy belongs to F. So range is set 6, 7, 8. Now this 6 is the image of 1, 1 is the pre-image of 6, 7 is the image of 2, 2 is the pre-image of 7. Now domain is defined as set of all values for which the function f is defined. Now domain equal to set of all x such that ordered pair xy belongs to f, and range is set of all y such that ordered pair xy belongs to f. Always range is a subset of codomain, maybe range is equal to codomain. Now in this case, domain is equal to set 1, 2, 3, which is equal to A. Codomain is set B and range is set A, B, C. Now a function acts as a machine. So നമ്മൾ മാങ്ങയാണ് ഉപയോഗിക്കുന്നതെങ്കിൽ, മാംഗോ പൾപ്പാണ് ഈ മെഷീൻ്റെ അകത്ത് ഇടുന്നതെങ്കിൽ നമുക്ക് കിട്ടുന്ന റിസൾട്ട് മാംഗോ ജ്യൂസ് ആയിരിക്കും. ജ്യൂസ് മേക്കറിൻ്റെ അകത്ത് മാംഗോ പൾപ്പാണ് ഇടുന്നതെങ്കിൽ നമുക്ക് കിട്ടുന്ന ഔട്ട്പുട്ട് മാംഗോ ജ്യൂസ് ആയിരിക്കും. അതുപോലെ നമ്മൾ ഈ ജ്യൂസ് മേക്കറിൻ്റെ അകത്ത് പൈനാപ്പിളാണ് ഇടുന്നതെങ്കിൽ, നമ്മുടെ ഇൻപുട്ട് പൈനാപ്പിൾ ആണെങ്കിൽ നമ്മുടെ ഔട്ട്പുട്ട് എന്തായിരിക്കും? പൈനാപ്പിൾ ജ്യൂസ് ആയിരിക്കും. അതുപോലെ തന്നെയാണ് ഫംഗ്ഷൻ. Now here we have a function from A to B, minus 2 to 4, 2 to 4, minus 1 to 1, 1 to 1, 0 to 0. This function is f of x equal to x square. Here A and B are finite sets. Domain equal to minus 2, minus 1, 0, 1, 2, which is A. Codomain is set B and range is equal to set 0, 1, 4. 2 has no preimage, 3 has no preimage. So range equal to 0, 1, 4. Now the same function f of x equal to x square from R to R. Set of all real numbers to set of all real numbers. In this case, this function is defined for all real numbers. So domain of this function is R. Domain equal to R, set of all real numbers. Now here y value is from 0 to infinity. So range is equal to 0, infinity, closed at 0. അപ്പോൾ നമ്മൾ ഫൈനൈറ്റ് സെറ്റിൽ പറയുന്ന പോലെ ഇവിടെ നമുക്ക് എലമെൻസിനെ ലിസ്റ്റ് ചെയ്യാൻ പറ്റില്ല. സെറ്റ് -2, -1, 0, 1, 2 അതുപോലെ നമുക്ക് ആറിലെ എല്ലാ എലമെൻസിനെയും ലിസ്റ്റ് ചെയ്യാൻ പറ്റില്ല. അപ്പോൾ നമ്മൾ സെറ്റ് ഓഫ് ഓൾ റിയൽ നമ്പേഴ്സ് ആർ എന്ന് എടുക്കണം. അതുപോലെ റേഞ്ചിൻ്റെ അകത്ത് വരുന്ന എലമെൻസിനെ നമ്മൾ ഇതുപോലെ ഇൻ്റർവെലിൻ്റെ ഫോമിലാണ് ഇവിടെ എക്സ്പ്രസ് ചെയ്യുക. ഇവിടെ റേഞ്ച് ഇസ് ഈക്വൽ ടു 0, ഇൻഫിനിറ്റി, ക്ലോസ്ഡ് അറ്റ് 0, ഓപ്പൺ അറ്റ് ഇൻഫിനിറ്റി. When a point xy belongs to F, set of all x such that ordered pair xy belongs to F is the domain of F, and set of all y such that xy belongs to F is known as range of F. Now for the function f of x equal to x, here this function is defined at all real numbers. So domain is equal to R, and here y values is set of all real numbers. So range is also set of all real numbers R. Now in the case of function x square, domain is R and range is 0 to infinity. The minimum value of y here it is 0, and here graph is increasing, y value is increasing and tends to infinity. So the range is 0, infinity, closed at 0. Now for the function x square plus 2, domain is R, range is 2 to infinity, closed at 2. Now consider the function x plus 2 whole square plus 3. Domain is R, range is 3 to infinity, closed at 3. Modulus of x, domain is R. The function is defined for all real numbers. So domain is R and the range is 0 to infinity, closed at 0. For modulus of x minus 2, domain is set of all real numbers, and here this point is 2, 0, y value is 0 and the graph is increasing, y value is increasing, so range equal to 0, infinity, closed at 0. Now this function is modulus of x minus 2 plus 3. Domain is R, range is 3 to infinity, closed at 3. Floor x, here domain is R and y value, here the y value is 0, and in this case here y value is 1, here y value is 2, and here y value is minus 1, here y value is minus 2. So y takes only integers. So range of this function is set of all integers. Domain is R, range is set of all integers. Now consider the function 1 by 2 into floor x. 1 by 2 into floor x. Domain is set of all real numbers. And here y value is 0, here 0.5, 1, 1.5, etc. Y value is 0.5. Here y value is 1.5. Here it is minus 0.5, minus 1, minus 1.5. So here domain is R, range equal to etc. minus 1, minus 0.5, 0, 0.5, 1, 1.5, etc. Now next function is floor x by 2. Domain is R. Here y value is 0. Here y value is 1. Here y value is 2, etc. So domain is R and range is equal to set of all integers. Now here x minus floor x. The function is x minus floor x. Domain is set of all real numbers and the range is 0, 1. Y varies from 0 to 1. When x is equal to 1, we get 1 minus 1, 0. So this point is 1, 0. This point 1, 0 belongs to graph, but 1, 1 not belongs to graph. 2, 0 belongs to graph, but this is not the image of 2, etc. So range is equal to 0, 1. Y value is from 0 to 1. So range is equal to 0 to 1, closed at 0, open at 1. This point is not in the graph. Here this point is not in the graph. This point 2, 1 is not in the graph. So y takes values from 0 to 1, but this 1 is not a y value. So range is equal to 0, 1, closed at 0, open at 1. Okay, vertical line test. Vertical line test is a visual way to determine if a curve is a graph of a function or not. തന്നിരിക്കുന്ന curve function ആണോ അല്ലയോ എന്ന് കണ്ടുപിടിക്കാനാണ് നമ്മൾ vertical line test ഉപയോഗിക്കുന്നത്. If a vertical line intersects a curve more than once, then for one value of x, the curve has more than one value of y. Then the curve does not represent a function. If all vertical lines intersect a curve at most once, then the curve represents a function. Vertical line തന്നിരിക്കുന്ന curve ഒറ്റൊരു പോയിന്റ് ഇന്റർസെക്ട് ചെയ്താൽ ഫംഗ്ഷൻ ആണ്. ഒന്നിൽ കൂടുതൽ പോയിന്റ്സിൽ ഇന്റർസെക്ട് ചെയ്താൽ ആ തന്നിരിക്കുന്ന curve ഫംഗ്ഷൻ അല്ല. Consider a vertical line f. F is x equal to 3.1. We can move this vertical line. By moving this vertical line, we get different vertical lines in the xy plane. Now consider the graph of g of x minus 5. Now when we move this vertical line along this line x minus 5, this vertical line intersect this graph of x minus 5 at a single point. So this graph represents graph of a function. When the vertical line intersect at a single point, that function, that is here x minus 5, represents a graph of function. Now when we consider graph of y square equal to 4x, y square equal to 4x. Now here vertical line intersects the given graph at 2 points, C and B. When we move this vertical line, we get different values for C. When x is 1, we have two different values for y. Here x value is 1, C is the point 1, 2 and B is the point 1, minus 2. For the value x is equal to 1, we have two y values. So this curve is not a graph of a function. For a single x in the domain, x has two images, 2 and minus 2. So y square equal to 4x is not a function. Now consider x square plus y square equal to 9. X square plus y square equal to 9. In this case also we have two points of intersections. Here we have a point and here we have another point of intersection. So this vertical line intersects this graph at 2 points. So this is not a function. X square plus y square equal to 9. The circle is not a graph of a function. Now consider graph of mod x. Vertical line intersect at a single point. So mod x, this graph represents a function. Graph of 1 by x is also a function. Then consider 2 raised to x. Vertical line intersect at a single point. So this curve represents graph of a function. Log x, e raised to x. Log x is a function. Then e raised to x is a function. Now consider the graph of x square into e raised to minus x. X square into e raised to minus x. When we move this vertical line, it intersects at a single point. So this x square e raised to minus x is also a function. Now we have three functions: sin x, modulus of sin x, and sin modulus x. Now sin x represents, this curve represents a function. Now consider modulus of sin x. This is graph of modulus of sin x. Here this is also a function. Now this is graph of sin modulus x. Vertical line intersect at a single point. Now consider curve y square equal to minus 9x. Now when we move this vertical line to left side, now this vertical line intersect given curve at two different points. For the same x, we have two different y value. For one value of x, there are two images. So this curve does not represent a function. Y square equal to minus 9x is not a function. Now consider this graph. Now when we move this vertical line, now here vertical line intersect given curve, given graph at two different points. So same value of x, we have two y values. So this is not a function. Now consider this graph. Here vertical line intersects at 3 points. Vertical line intersects at J, K and L. For the same x value 2.2, we have 3 y values. So for this x there are 3 images. Okay, so this is not a function. Now consider two sets A and B. A is equal to set 1, 2, B equal to set 1, 2. Find all functions from A to B. So ഇവിടെ നമ്മൾ എയിൽ നിന്ന് ബിയിലേക്കുള്ള എല്ലാ ഫങ്ഷൻസും കണ്ടുപിടിക്കണം. Now consider functions. These four are the functions from A to B. Here 1 to 1, 2 to 1, 1 to 1, 2 to 2, 1 to 2, 2 to 1, 1 to 2, 2 to 2. ഈ 4 ഫങ്ഷൻസ് മാത്രമേ എയിൽ നിന്ന് ബിയിലേക്ക് ഉണ്ടാകൂ. ബാക്കി ഇവിടെ 2, n of A is 2, n of B is 2. So there are 2 raised to 4 relations. 2 raised to 4, that is 16 relations. അതിൽ ഈ 4 എണ്ണം മാത്രമേ ഫങ്ഷൻസ് ആയിട്ട് വരും. അപ്പോൾ ഇവിടുത്തെ ഓരോ എലമെൻറ്റിനും ഒരു ഇമേജ് മാത്രമേ ഉള്ളൂ. ഇത് 4 എണ്ണം ഫങ്ഷൻസ് ആണ്. Now second one, let A equal to set 1, 2, B equal to set 4, 5, 6. Here also find all functions from A to B. Here n of A is 2, n of B is 3. Now here these are functions from A to B. 1 to 4, 2 to 4, 1 to 4, 2 to 5, 1 to 4, 2 to 6. ഇപ്പോൾ 1 4ലേക്ക് പോകുന്ന സമയത്ത് 2നെ നമുക്ക് 4ലേക്ക് കൊണ്ടുപോകാം, 5ലേക്ക് കൊണ്ടുപോകാം, 6ലേക്ക് കൊണ്ടുപോകാം. Now consider 1 to 5. 1നെ 5ലേക്കാണ് നമ്മൾ മാപ്പ് ചെയ്തിരിക്കുന്നത്. അന്നേരം 2 to 4, 2 to 5, 2 to 6. ഇതുപോലെ 3 എണ്ണം കിട്ടും. Now take 1 to 6, then 2 to 4, 2 to 5, 2 to 6. Total 9 functions ആണ് ഉണ്ടാവുക. In general, if n of a is equal to m, n of b equal to n. ഇതിപ്പോൾ നമ്മൾ ജനറൽ കേസ് ആണ് കൺസിഡർ ചെയ്യുന്നത്. Number of functions from a set A to another set B. In a function, every element of the set A must be mapped to an element of B. Number of ways of choosing an image to each element of A is n. Now consider set A with m elements and set B with n elements. And consider a function from A to B. അപ്പോൾ A1നെ B1ലേക്ക് മാപ്പ് ചെയ്യാം, അല്ലെങ്കിൽ A1നെ B2ലേക്ക് മാപ്പ് ചെയ്യാം, or we can map A1 to B3 or A1 to Bn. So number of ways of choosing an image to A1 is n, number of ways of choosing an image to A2 is n, etc. Number of ways of choosing an image to AM is n. So total number of functions equal to, by using product rule, n into n into n, m times. There are m elements in A, so m times. So number of functions from A to B equal to n raised to m, or order of B raised to order of A. Now here another example. Consider A equal to set 1, 2, 3 and B equal to set AB. Now functions from A to B are, here n of A is 3, n of B is 2, so there are total 2 raised to 3 functions. So there are 8 functions. Order of B raised to order of A, 2 raised to 3 functions. And the functions are F1, map 1 to A, then 2 to A, 3 to A, 1 to A, 2 to A, 3 to B, 1 to A, 2 to B, 3 to A, 1 to A, 2 to B, 3 to B. 1നെ എയിലേക്ക് മാപ്പ് ചെയ്യുമ്പോൾ നമുക്ക് ഈ 4 ഫങ്ഷൻസ് കിട്ടും. അതുപോലെ 1നെ ബിയിലേക്ക് മാപ്പ് ചെയ്യുമ്പോൾ അതേപോലെ ഇരിക്കുന്ന 4 ഫങ്ഷൻസ്, അതായത് 1 to B, 2 to A, 3 to A, 1 to B, 2 to A, 3 to B, 1 to B, 2 to B, 3 to A, 1 to B, 2 to B, 3 to B. അങ്ങനെ ടോട്ടൽ 8 ഫങ്ഷൻസ് കിട്ടും. That is order of B raised to order of A. So number of functions from a finite set A to a finite set B is order of B raised to order of A. Thank you.